School of Marine Science and Engineering in Plymouth University. His current research interests include soft computing, fault detection, and diagnosis.
Good afternoon. Today I'm going to speak about my project, intelligent fault diagnosis of NM underwater legal electrical thrust motor. Actually, the outline of this work including the following points: the aim of fault diagnosis and condition monitoring task, the major faults in an electrical machine, and the proposed fault diagnosis, and using dynamic neural method for fault diagnosis and conclusion. We should know in the first step why we need to use why we need fault diagnosis. I think it's simple to know, because we need to optimize maintenance, we need to increase the reliability of electrical power system, we need to decrease the cost damage, and also we need to get, especially for the person who works with this machine, he needs to have the spare part required before the fault occurs. So that to achieve these aims, we need to build fault detection and diagnosis suitable to get per machine motor situation in every stage, and also use soft computing instead of using traditional techniques to increase reliability and accuracy. And I think we know electrical motors, because I deal now with thrust motor. Electrical motors deal with many applications, with civil and with military applications. So that now we can see, I said maybe different terms. I said fault detection and fault diagnosis, but we should know what's meaning of fault detection. I think fault detection meaning decide where if our motor is working in normal and abnormal situation. And fault diagnosis decide the location of this fault. And there is more advanced, it's fault identification, decide the severity of this fault, decide detection, diagnosis, and also severity of this fault. And this is more advanced with respect to fault diagnosis. In electrical power system, fault can be classified in two types: electrical faults and mechanical faults. Actually, all these faults related each one with other, and always the mechanical faults will lead to electrical faults if it's not hit in the suitable time. Rolling element bearing faults represent the main type of faults in electrical motors, represent about 40% of faults in electrical motor, and the stator winding faults represent 30% of faults in electrical motor. But I said all these faults, each one are related with other, because rolling element bearing faults will lead to eccentricity faults. This meaning the air gap between stator and rotor of electrical motor will be uniform, so that the flux will be changed, current will be changed, the voltage will be changed. So that bearing will lead to eccentricity to lead to will affect on electric motor performance or parameter, so that each one related with other. Actually, when fault occurs, there are many indications. I said motor parameter will be changed, the current, voltage, and also temperature will increase. And there also there are many techniques can be used to know the situation of our motor. Some researcher or some techniques monitoring just the electrical parameter, others using mechanical parameter like vibration, others using temperature, if it's temperature increase, and other researchers using chemical parameter like monitoring oil, and this will give you indication if motor working in normal or abnormal situation. And there are, if we divided the techniques we choose to fault diagnosis, this techniques can be divided in 4 types: model-based techniques and signal processing techniques, soft computing, and hybrid techniques. Each one from these techniques there is advantage and disadvantage. For model-based techniques like parameter estimation or observer or parameter relations, the disadvantage for this technique is related with mathematical model. We need accurate mathematical model to get the best result, and this is difficult to write mathematical model without approximation. With signal processing techniques, we need expensive equipment and we face a problem with the reliability. And recently, all researchers deal with fault diagnosis and condition monitoring. They deal with soft computing, especially using like neural, fuzzy, genetic, and support vector machine or expert system. Or using hybrid techniques. It's hybrid techniques using two techniques the same to take the advantage of both instead of using one. And my project, actually I used the proposed fault diagnosis which I will speak now. I use it with different type of faults, with rolling element faults, with stator winding faults, and with imbalance mechanical load faults. Today I will speak about imbalance mechanical load. This with the thrust motor and with blade faults. This is actually with this type of I think for underwater vehicles, this is used by scientific in different tasks, so that the reliability of this type of machine is more important. And blade faults is usually occurs when sudden with stones or any hard material. So that to diagnose this faults, I propose this techniques is including by monitoring vibration. Actually now I got my monitoring vibration, and I will develop monitoring vibration plus current. Monitoring vibration and processing this vibration, because not all this data is useful to give you indication about motor situation. First step, monitoring, get this vibration signal. Second step, extract the useful features using discrete wavelet transform, and then reduce these features to overcome the limitation of redundancy features, because not all these features are useful. Some of these features will decrease the accuracy, so that I extract the features and reduce these features to get the best features can give me indication about motor situation. And then the last stage, fault classification. We did experiment test in Plymouth University control lab. We simulate blade faults in control lab with different severity, and using accelerometer to get the vibration signal, and then processing this data using data processing system. For this one, I think for the first step, using discrete wavelet transform instead of traditional techniques. Traditional techniques means fast Fourier transform or short time fast Fourier transform, because this is technique it is usually used, but I found fast Fourier transform is not useful with non-stationary signal, and short time fast Fourier transform actually it's give me information in time and frequency domain, but it's face a problem with Windows. So that I found wavelet and especially discrete wavelet transform can give you information in time and frequency domain and overcome the limitation of the fast Fourier and short time fast Fourier transform. And using level 3 wavelet level 5 wavelet transform. Each level can I make a scale and translation of my signals to get the best resolution. All with wavelet transform there is many levels, so that we should use trial and error to find which levels and which model wavelet give you the best result, so that I'm using the batch 2 and level 4, level 5 to get the best result. And the second stage I said to decrease, because not all these features, wavelet features is important, so that I'm using orthogonal fuzzy discremental analysis techniques. These techniques can use to decrease the distance between features belong to the same class, and increase between features belong to different classes. So that I actually here in these figures, the red, green, and the blue, each one represent motor situation, represent motor normal, and motor and severity fault 1, and motor severity and fault 2. So that often or orthogonal fuzzy, this will make the distance between features in the same class as short as possible, and increase the features for different classes. then I used the OpenDA features or signal fuzzy features for in the last stage this fault for faulty classification. After get, extract the feature, reduce the features, and then faulty classification by using these features to training the neural networks. Actually, I'm using a neural network for faulty classification. A neural network, I think it's a parallel processing system. It's give more advantages with respect to all soft computings. With respect to fuzzy logic, it need the knowledge about the system. And but for the neural networks, I don't need any knowledge about the system. I just need data. This data which used to training, and some of these data will be used for training, and others will be used for testing. I use dynamic neural network instead of static neural networks. Static neural networks is more popular, but I found, because I deal with with dynamic system, so that I'm using dynamic neural networks. It's exactly the same structure of static neural network, but with feedback. This will help to get the best result and the best accuracy. And this is a structure I'm using the NRX dynamic neural network structure. The input will be the OpenDA features, and the output represent the logic, output represent the motor situation. It's working in normal and abnormal situation. And the last stage, because here the rest you can see here in this figure, this represents the relation between the target and output. Because I use OpenDA features, part of these features using for training, and the part used for testing. After testing this data, I get this figures. This exactly, I think it's a good result, and this makes the relation between the output and target. In the future, I need to develop these techniques, because now we diagnose faults, but it's more important to prognosis faults. I use this prognosis fault with rolling element pairing by make different fault severity. This will help to decide the lifetime of parts, and this will give you more information, more important information to overcome the limitations of faults. The conclusion I found from this work, basically WRAbed transform can give you good information or good features with respect to traditional techniques, and also my techniques of OpenDA or signal fuzzy. This will give you the best feature can be used to training in neural networks, and I found also dynamic neural network is better than static neural networks, especially with dynamic system. Thank you so much.
Thank you very much. Are there any questions for this presentation? I perhaps have one question. You monitor the vibration,
yeah.
And you have so a specific instrumentation.
Yeah.
You were mentioning that you will, in the near future or in the future, monitor the current. In this case, do we really need a specific instrumentation?
No, I'm sorry. I just now using accelerometer. Accelerometer give me vibration, but the problem with vibration, sometimes with low speed, the vibration don't give you good indication, and also vibration maybe belong to different mechanical parts, not just for this specific part. So that I need to develop these techniques using vibration plus current. Current will increase the reliability and also will not increase the cost, because already current sensor including in an electrical power system.
Other questions? I have one more open questions. Another one. So you check on the specific components,
Yeah.
with a specific measurement on these components. Have you the intent in the future to use some of the techniques which are related to model-related techniques, using the description of the whole systems to identify failure in some of the components?
Yeah. I said I use the same techniques with different parts. I using with rolling element bearing faults. I using with stator winding faults, this meaning electrical faults and mechanical faults. And with this one, with this faults, with the blades faults, with imbalance mechanical load, so that I using with different part of machine, so that I can use it with whole bars.
Thank you very much.
Thank you so much.
Other questions? No, thank you very much.